Now let's look at the incremental analysis topic, and let's pick an exercise from the textbook to illustrate the concept. So we're looking at page 138, exercise 8b2. Narcosis Diving Company is attempting to determine the best size of air compressor for their scuba diving operations. 5 alternative sizes are available, as shown below. Narcosis has a budget of $250,000 and a minimum acceptable rate of return of 20%. The life of these compressors is 12 years, and the salvage value of each is 0. Which compressor should be chosen? What is the incremental rate of return of choosing the super compressor as compared to the regular compressor? What is the incremental benefit cost ratio of choosing the deluxe compressor compared to the regular compressor? So here are the expected cash flows per project. We have at the beginning 5, and with annual revenue and initial cost per each. So the information for exercise 8b2 on page 138 is that the minimum acceptable rate of return is 20%. Each air compressor lasts 12 years. The budget is $250,000 and the expected salvage value is 0. Now, given the budget, remember step 1 in incremental analysis is to eliminate anything that is over budget. Since we only have $250,000, you can see that the massive air compressor is immediately eliminated. Then we are left with the remaining 4 air compressors to evaluate. First step, check out if they are all economically viable. So let's do that using, for example, since they are going to ask us to use the internal rate of return and the BC ratio, let's use something else. Let's say net present value to check if the remaining 4 options are economically viable. So this note that is basically comprised of an initial cost and an annuity for each one of them. So we just need to figure out if, given the minimum acceptable rate of return of 20%, if there is anything here that has a negative net present value. So we have the project Econ net present value equal to the present value of all cash flows. So we have the $50,000 and of investment, and then an annuity of $7,000 of positive cash flow. Given the minimum acceptable rate of return of 20% and that these are 12-year projects, is the net present value positive for the Econ compressor? We need to find that out. Then the regular, they all follow the same kind of cash flows, which is an initial investment followed by a stream of annuities, positive annuities. So for the regular is 27,000. The discounting factor is the same. They are all 12-year lived projects. And then we have the super with an $160,000 investment plus $40,000 annuity. And then we have the deluxe with $220,000 initial investment for a $55,000 annuity. So we need to check if these there is any net present value that is negative, so that we can eliminate that option. So the first one is going to give a net present value of negative $18,925. So that's going to be eliminated as a negative present value. Now let's see the regular. The regular gives positive $19,858, so that's okay. The super gives a net present value of positive $17,568, so that's okay. And now the deluxe. The deluxe gives 24,957, let's say, rounded, so that's okay too. Meaning we are left with 3 economically viable options, and that's where we're gonna implement our Defender Challenger approach. The next step is to rank them from the cheapest option to the most expensive option. So there's just 3 of them. So the cheapest one is project R, the second one is project S, and the third is the most expensive, D. Now we're going to start the defender-challenger approach by comparing project R to project S, where R is going to be the defender because it is the cheapest, and S is going to be the challenger because it's the next least expensive. Whoever wins from this combat, let's say, is going to then be the defender on the next round against project D. So let's see who's going to become the defender for next round. So as we just saw, the defender is going to be the cheapest option of the economically viable projects, and that was project R, which required an initial investment of $100,000 and then generated a positive cash flow of $27,000 per year. The second least expensive was the challenger among the economically viable options and generates a positive cash flow of $40,000 per year. So the basis of the defender-challenger approach is to find the increment, meaning the differences in cash flows. And here you'd see, subtracting these two values, that you get negative 60,000, and subtracting these two values you get positive 13,000. So the question is the extra $60,000 investment worth it the extra $13,000 per year that S generates compared to project R? And the question asked us to assess this using the internal rate of return and the BC ratio. So let's use the internal rate of return, which you know it's the rate that makes the net present value equal to 0. So the computation will be forcing net present value of these incremental returns to be 0. What is the interest rate that enables that? So negative 60,000, present value of it is 60,000, negative 60,000 because it happens at time 0, is the initial investment, the initial cost. And then there is the $13,000 annuity that we need to discount to times 0, given this unknown interest rate over 12 years. So what is the interest rate that this makes this equality hold? And the result is 0.1897, the same is to say 18.97%. This would be the internal rate of return. So is it worth it? And the answer is no. Why? Because our minimum acceptable rate of return is 20%. Investing extra 60,000 for extra 13 in annuity has an internal rate of return of only about 19%. So since the internal rate of return is lower than the minimum acceptable rate of return, we reject the challenger. The extra investment is not worth it. The same is to say, defender wins. That is, project R wins. So project R won this fight and is going to now be compared with the next least expensive option, and that was the deluxe option. So the defender remains the same, but the challenger changes. And let's look at the cash flows from the challenger. That's the deluxe alternative, which requires an investment of $220,000 for an annuity of $55,000. Therefore, is the extra $120,000 worth it the extra $28,000 in annuities? Now let's use the BC ratio just to be different. If you were to use the internal rate of return to assess these, the challenger would win if the internal rate of return was greater than 20%. In the case of using the BC ratio, the challenger wins if the BC ratio is greater than 1. If not, then the defender wins. Now remember, the BC ratio is equal to the summation of the present value of the benefits divided by the summation of the present value of the costs, both evaluated at the minimum acceptable rate of return. So, the present value of the benefits is the extra in annuities. So is the present value of these extra 28,000 discounted at the 20% minimum acceptable rate of return over 12 years, greater than the present value of the costs, where the cost is 120,000. Recall, I'm not using the negative sign for 120,000 because it's already costs by definition. So this would give 124,298 as the present value of the benefits, and you can see this is going to be greater than 1, so the challenger is going to win. Namely, this is 1.036, greater than 1. Therefore, challenger wins. That was project D, meaning that is worth it to spend the extra 120,000 in order to get extra 28,000 over 12 years, given that our minimum acceptable rate of return is 20%. If this ratio was less than 1, then the defender would have won. Now let's do this very same computation using the external rate of return. The textbook doesn't ask, but just for the sake of having an example for the external rate of return. So the external rate of return is the rate that makes the future value of all costs, when evaluated at this so-called external rate of return, equal the future value of all benefits, when evaluated at the so-called reinvestment rate. Here we don't have a reinvestment rate explicitly given to us, so we're going to use the minimum acceptable rate of return. So the future value, in this case is going to be of the benefits, is the future value of the annuity. So that is the 28,000 times 1 plus the interest rate to the power of n minus 1 divided by the interest rate. And on the left hand side we have the future value of the cost. The cost is a single cash flow at time 0 that needs to be pushed up to time 12. So we have the 120,000 pushed forward at that interest rate we want to find over 12 years. And the interest rate that makes this equality hold is 0.2035. The same is to say 20.35%. And this is the external rate of return. Note that we reach the same conclusion because the external rate of return is greater than the only interest rate we have as a proxy. Right? We don't have a minimum external rate of return given in the exercise, but we have a minimum acceptable rate of return. So we're going to use that as the comparison. And because 20.35 is greater than 20, the challenger wins. And therefore we would reach the same conclusion that D is the best project. So that's it for incremental analysis. You are now ready to do the quiz.